Hello everybody, my name is Pramod Paudel and my project for this summer is OpenCV DSP Acceleration. Before I begin with the presentation, I would like to give you a quick overview about this presentation. At first, I will talk about what OpenCV DSP Acceleration is. Then I will talk about what all algorithm I am going to accelerate. Then about my design architecture. After that, I will talk about the present status of my work and what I will be doing next. And finally, I will provide links to my project. To begin with the description about my project, let me start with the definition of OpenCV. OpenCV is a highly optimized computer vision library. It is designed in such a way that it can take advantage of Intel's integrated performance primitive library if found, and this basically can further enhance the performance of OpenCV libraries. So what about OpenCV on BeagleBoard? Okay, to answer this question, let me tell you that there is no problem to work with OpenCV on BeagleBoard. So what about the performance? We all know that BeagleBoard houses OMAP 3530, which has a heterogeneous processor architecture, and one of its core is C64X plus DSP. Given the power of DSP core to BeagleBoard, there lies an opportunity to further accelerate the performance of OpenCV algorithms. Thus, the goal of this project is to use this on-chip DSP core to further accelerate some of the OpenCV algorithms and to design an application to demonstrate the use of these algorithms. After having knowledge about my project, let's take a look at what all algorithms I am going to accelerate. OpenCV basically provides more than 500 algorithms, and given a limited time of this summer, it is almost impossible to accelerate all of these algorithms. Thus, I have selected quite a few algorithms like CV Sobel, CV DFT, CV Average Standard Deviation, and CV Integral to accelerate using on-chip DSP core. Avoiding the core details about these algorithms, let's take a look at how am I going to implement these algorithms. Currently, if you have to work with OpenCV on BeagleBoard, there will be an application which will call upon OpenCV libraries. These libraries works only on the GPP side, and in my case, it is ARM Cortex-A8. Now, my design architecture will be slightly different from the above. There will be an application as usual. This application will now call either ARM-based OpenCV library, which are not accelerated, or ARM-based OpenCV DXP accelerated library. This DSP accelerated library will use codec engine framework to do the remote procedure call, inter-processor communication through DSP link, and different other housekeeping jobs. As all the algorithms are non-visa type, a universal API will be used to access the libraries that execute on the DSP side. In this way, now the computation-intensive algorithm can be executed on the DSP core. Let us now see what all I have been able to do so far and what I'll be doing further. So far, I have an ARM library that can perform Sobel 3x3 algorithm on the DSP side. This library works well for single-channel image with depth of 8-bit. Also, I have one-dimensional DFT algorithm working on the DSP. However, it does not support full functionality and further work is needed. Further, I have also tested the Sobel library with images from the webcam and found to work well. As you can see on the right-hand side of this slide, some of the images, those images are taken from my webcam and then processed using the Sobel algorithm, accelerated Sobel algorithm. Regarding my future work, I will next integrate these libraries with existing OpenCV libraries and add further support for other algorithms. Also, I will be designing an application to demonstrate my work. Before I wrap up with this presentation, I would like to provide you with few of the links to my work. You can find the source repository at the address shown on the slide. Also, the procedure to build example is provided at the address shown on the slide, and you can track my progress at pramodpaudel.blogspot.com. Okay, that's all about this presentation, and if you have any queries regarding my work, please feel free to contact me at my email address or talk to me over BeagleBoard IRC. Thank you so much and have a nice day.